Okay. Ready? 1, 2, and 3. Today it's Wednesday, March the 11th, 2026, and in this video we're going to show pretty much what it's listed as a procedure in report 620 to test Enerpro digital board. What we're going to need for this is a wire harness similar to this with an inline resistor, and if the AC voltage, the three-phase source to be used is 380 or 480, the recommended resistance value is 2 mega ohm and at least half a watt resistor. So these three resistors are one resistor per conductor inline, and in this particular case we're going to test bench at 480. So here we have our phase loss, here we have our wire. Our wire has those three inline resistors, and that cable, that wire harness, either lands here on J7 or on J5. In the particular case of this customer, we can make them land on J5, position 1 the A, position 3 the B, and position 5 the C reference. This is per plus patrol, drawing PP1S-3-S38-BL-E052 that Enerpro received from the customer. So the very first thing that we need is 24 volts AC from a power supply, just the way it's shown here, between 1 and 2. Let's go ahead and power the board. When we power the board, again, we expect the board to be configured for zero cross. I mean, not for zero cross, but phase angle. So we're going to have this relay selected in phase angle control. We'll see that only when 24 volts AC are applied, right here, positions 1 and 2 of J3, all 4 LEDs are on. The only one that it's not on, it's the zero cross. So these are the 12 volts, the 3.3 volts, the inhibit, and the phase loss. Okay. The next thing that we're going to do is we are going to apply for 480. But once again, very important to have that resistor to attenuate that. If we don't have that resistor, we for sure will damage the board. So once we apply the 483 phase source, now the board has cleared the phase loss LED. And the only thing keeping the board now from enabling or inhibiting it's a switch between positions 4 and 6. That's the instant enable, and that once again it's there. Positions 4, I1 not, position 6, 12 volts. And finally, the last thing that we're going to do is we're going to bring in this particular case, the board is configured for 0 to 5 volts. So we're using the 5 volts from the board, and we're using a potentiometer to apply on SIG high at J3 position 10, 5 volts. This particular board, according to the customer schematic, uses 4 to 20 milliamps. Once again, just for illustration purposes, we're using the 5 volts from the board and using a potentiometer, and we bring in the delay angle command. So again, we've applied power, had our 4 LEDs on, applied the phase loss. Now we only have 3 LEDs on, only 1 red LED. The minute that we fire by enabling, go ahead Tony, close that switch between J3 positions 4 and 6. Now the only 2 LEDs, this is the normal operating mode, the only 2 LEDs that will be on will be the 3 volts, 3.3 volts and the 12 volts. Okay. Now at this point we can bring in our oscilloscope. We will only need really 2 probes. One probe is on TP4. TP4 is the reference right here. Test point 4, that's the reference, that's the only reference we need. Make sure that we have grounded. And then first thing that we want to do is take a look at the different test points for the pulse modules, keeping in mind that the board that the customer has fiber optic transmitters. But one thing from report 628 is at this point all red LEDs in the fire transmitters should be on. So now I have TP4 as my yellow channel, 50% duty cycle. And then now I have my traveling probe for the first pulse module or for the first fiber optic transmitter on test point 1. Then we're gonna move to, can you move that, Tony? To test point 8, which is just to the next test point. And now we see an output. There's a reference. Our reference will change. And then just keep on going, Tony. The next one. So at this point we verified the third one, and then the fourth, and so forth. We don't have to go to the fifth or the sixth, but that way we will show that we have all 6. Now, the last thing that I want to point out is sig high right now. Can you tell me what sig high is?
It's 0.
It's 0. It's minimal.
The channel 3 is on sig
Okay.
high.
All right. Oh, channel 3 is on sig high, so we're at 0. So let's go ahead and we don't have to. We could have used a meter, right?
Okay.
So let's go ahead and bring in sig high. We can see sig high going up, and we can see this output out of TP1 moving as sig high changes. That of course will be the equivalent of the customer changing the 4020, going from 4 milliamps to 20 milliamps, and seeing. And the same will apply to all the different waves. Can we move now to pulse module 2, test point 8 again, Tony? And again, so can you go ahead and say that? And we have now that change in the delay. The reference, by the way, will never change, so we see the reference, the delay angle decreasing. We see sig high, the 0.5, and we have the reference that doesn't move on TP4. So again, this is the end of this video, and we pretty much shown on our standard digital board how to check for the outputs and how to verify that works okay.